after discussing about various limitations of digital human modeling software and how we can adopt this digital human modeling technology, what are the steps to be taken for wide adoption in developing countries, we have already discussed. Now we are going to discuss future research scope in the field of digital human modeling. In the coming few slides, we will discuss about opinion or view of various researchers, what they mention about the future scope of the digital human modeling software. Many of these references mentioned here are old, and as these are the old references, so many of the future research scopes mentioned by those researchers are right now actually not future research scope, those have already been addressed. Apart from that, there are so many aspects which are needed to be addressed in the while we are going to develop digital human modeling software, or while we are thinking about new application of digital human modeling software. So first we want to mention the opinion of Badler 1997. He projected that the advancement of virtual humans will help in presenting information through training aids, virtual experiences, and even teaching and mentoring. He also predicted that virtual humans will help to save lives by providing surrogates for medical training, surgical planning, and remote telemedicine. Now in 2016, if we look at various digital human modeling softwares available in the market, then we find many of these issues have already been addressed. Now digital human modeling software or full digital anatomy of human body is already been created, and those are being used for medical training, surgical planning, and telemedicine. This type of physiological human model is also being used for medical training of the nurses, as we have also seen in our earlier discussion while we are discussing about application of digital human modeling software in healthcare industry. Badler 2000 proposed that digital human modeling tools need to automate fine control of the mannequins with options of manual override by the user at any point or at any level. Digital human modeling software or its capability should be automated, but there should be some option so that as per our requirement or user requirement, we can override those automatic features. For example, DHM should know, he mentioned in this way that DHM should know how to sit on a particular seat or chair, then how to use a display. So those options should be there. What is needed by the computer is to take on the labor intensive task of mannequin control to free up the human effort to consider the information provided by the tool. So it means that the computer should be capable, or the digital human modeling software should be capable, or it must have that capability so that we can easily position digital human mannequin on the particular workstation, or we can interface with particular product. For that purpose, or much effort should not be required. On the other hand, while human is or user is free, or while users are not engaged in this task, labor intensive task for manually positioning digital human mannequin on the respective seats or workstation, then he or she will be free to process the information provided by the tool. Various analysis can be performed. But otherwise, what happens? Users expend most of the time for proper positioning, proper interfacing of the digital human model with the workstation or product model. So if that can be done automatically or very easily, then it will be very user friendly. He also proposed to improve the reliability and consistency of the digital human models. Enhancement of the model of human performance in the synthetic environment is one of the area for future research. Current evaluations require the expert to make a judgment of the user's ability to operate in an environment for a prolonged period. So, at the situation right now, the digital human models, they are not capable of simulating the effect of environment while people are in that environment or in that workplace for a prolonged period. So, in future, so right now, so here, as he mentioned, current evaluation require expert. So, expert or who are using the digital human modeling software, he or she has to make the decision that what should be the effect while that environment or that workstation is being used by a person for the longer duration. Models of attention and information processing capacity could be used to highlight the features of design which might lead to insupportable load under situation of high activity or likelihood of error during period of low activity. So, model of attention and information processing capability could be used, because right now this type of capabilities are still lacking. So, this will be very much helpful. Chaffin 2005 projected that the existing posture and motion prediction models in digital human models would change the model based on real motion data, would change to a model. So, right now in 2005, while Chaffin mentioned, the many of the digital human modeling softwares are using inverse kinematic model. So, he mentioned that this model should be changed to a model based on real motion data to assure validity for complex dynamic task simulation. Valid human posture and motion prediction model are needed to be developed. This can be combined with psychological and biomechanical model, and it will be a very powerful tool for predicting dynamic human performance and population specific limitations. So, he very rightly mentioned that real human motion data which can be captured through 3D motion analysis system. So, that human motion data can be incorporated in this type of software. Not only motion capture data, along with that, if it is possible to incorporate psychological data, biomechanical model, then it will be a powerful tool for predicting dynamic human performance, and also for population specific limitation, because from population to population range of motion varies, population to population their force capabilities varies. So, this is very important. There is concern that special populations or individuals may have dynamic reach capabilities that are quite different from what is now published in some ergonomics guides for the handicap. So, for special population, not only for physically challenged person, but even for population to population, the reach capability, as I mentioned earlier, the range of motion for particular body joints, force capability, it also varies. Not only from population to population, from individual to individual in the same population, it also varies. So, this type of issues to be addressed while we are further developing digital human models. It is imperative that the research on human motion and biomechanical capabilities are needed to be carried out in ways that provide predictive and valid models that can be incorporated into existing digital human models. So, predictive and valid models are needed to be incorporated in the existing digital human model tools. A range of behavioral controls can be specified, allowing the movement of the human to be constrained based on the selected behaviors. So, human motion based on the selected behaviors are needed to be incorporated. The concept of ergometer indeed is needed to be developed, which will evaluate physical activity with the musculoskeletal disorder risk factors in order to enhance the user-centric design. So in this digital human modeling software, if ergometer concepts can be incorporated, which can, apart from posture evaluation, which can calculate the energy expenditure and many other aspects, so that while we are evaluating any workstation or workplace with digital human modeling software, then during that physical activity evaluation, we can also understand what would be the risk for musculoskeletal disorder, and thus in this way we can make the workstation more user-centric. Demiriel and Duffy 2007 stated that digital human model software provides solution for complex engineering design and analysis problem. Despite its advantages, further research and development is necessary to develop graphically advanced, virtually interactive digital human models which include cognitive and psychological aspects. So not only physical aspect, so in future research more cognitive and psychological physiological aspects are needed to be considered for human model working of human and working environment. Graphically advanced means more realistic digital human models will allow engineers to work in virtual reality environments to gain control in product design in earlier stages of product development. So they highlighted that this graphically advanced digital human models is needed to be used in virtual reality environment to gain control in the product design in earlier design development stage. Advanced computational processing capabilities will make it possible to develop advanced mathematical models for digital human modeling applications. A future development which includes full body finite human models may take the place of crash test bodies in transportation design. So they also propose that there is requirement of full body finite human models which can be used for crash testing in transportation design and in military applications. This will enable engineers to evaluate advanced human object and object to object interaction before physical prototyping. Advanced simulation capabilities with easy micro and macro motion control capabilities is required to allow engineers to test robotic devices which are controlled by human operator. So in this way, various aspects have been mentioned by Demiriel and Duffy in 2007 that these aspects can further be addressed so that digital human modeling software can be improved in its capabilities and it can overcome its existing limitations. Abdel Malik et al. 2007 forecasted that in future digital human model software like Santos will be more realistic digital human model that include anatomy, biomechanics, physiology and intelligence in real time. So he forecasted that during the development of Santos software under Virtual Soldier Research Initiative, they mentioned that in Santos software they are planning to incorporate all these features in 2007 and many of those features have already been incorporated now in 2016. Bob 2007 stated that in future design of information flow areas will become dominant. An example in this growing development of assistance system in cars. The application of digital human models will allow achieving the connection between information design and the necessity of geometric design of the equipment. So as the information processing, information flow are becoming more important in present day scenario, so Bob 2007 he proposed that the application of digital human modeling software must have that capability so that we can achieve the connection between information design and necessary geometric design. So how the information to be presented on the displays and accordingly what should be the geometric design of that equipment or display we can determine by using digital human modeling software based on the viewing distance, viewing angle and so many other aspects, and this will be very much applicable in automobile industry. Chaffin 2008 forecasted that in future an advanced performance model will be capable of not just demonstrating the physical consequences of high information loading tasks, but also aiding an analyst concerned with the cognitive consequences that might be associated with a physical feature in a vehicle or industrial process. As for example, larger display, magnifying mirror, head-up display, night vision display, stock or wheel mounted controls, audio warning system, tactile warning system and so on. So, Chaffin 2008 they mentioned not only physical consequences, but also we need to consider the cognitive consequences which are associated with many of these tasks. In future, a person performing an ergonomic analysis with a digital human model will be able to simulate many different types of tissue and even cellular responses that are expected from group of people when performing a particular physical activity. So, they also propose that research is required in this direction, so that in future we can simulate this type of tissue and cellular responses. Or 2015 predicted that in future work, mannequin families will be included in the simulation. Through these families, the workstation can be designed to fit a group of operators, not only for male median, because in many places we find that researchers only use 50th percentile digital human model for evaluating their workstation. In future, it will be interesting to simulate workstation with multiple mannequins. So, for a single workstation, these softwares must have that capability, so that we can go for evaluation of multiple mannequins simultaneously. Today, both IMM intelligently moving mannequins and IPS industrial path solution softwares are used, and the data is transferred between these systems. In the future, this software solution will be merged into one, facilitating simulation process. So, he proposed that merging of these two software are required for further advancement of virtual ergonomic evaluation process. With this software, it is possible to design the future assembly workstation that can be used to meet the globalization demand for higher productivity as well as future demographic changes for manufacturing industries in the developed countries. A biomechanical observational method that also include a time factor should be included. So, while you are thinking about the biomechanical evaluation, then not only body joint angle or muscle activity is needed to be evaluated, at the same time we need to consider the time factor. It should be possible to use multiple industrial robots or humans in the simulations. Mannequin families should be included in future solution. So, we will discuss more about these mannequin families. Johnson and Fletcher 2015 predicted that the user input can be gained through the use of virtual reality and mock-ups to identify physical usability and ease of access for structures along with qualitative comfort data. While we are evaluating with digital human modeling software, then we are mainly getting the quantitative data based on that analysis, but we cannot go for subjective evaluation or subjective likingness, dislikingness, all these issues, and their comfort, their perception about the comfort. So, for this purpose, Johnson and Fletcher 2015 predicted that if we can use input in digital human modeling software, if we can take input from virtual reality and mock-up study to identify the physical usability and ease of access of structures along with qualitative comfort data. So apart from digital human modeling software, what we can do, we can create physical mock-up, and through virtual reality system we can get the real users feedback, and based on that we can evaluate the workstation or model or product model. This information can be used to improve the design and help to mitigate the work related injuries and stress, helping reduce the cost relating to injuries and improved work performances. Nerat et al. 2015 assessed two digital human modeling systems widely used in industry for virtual ergonomics. Results supported the need of a more realistic human modeling, especially for biomechanical analysis and standardization of DHM. So another important aspect related to DHM is the standardization, because from software to software the result varies, so standardization is very important. This study opened the way of further research on the relationship between external body parameters, landmarks, measures, etc., and internal skeleton in order to reduce the errors in joint location. So, and improve the realism of current digital mannequins. So, generally while we are even going for motion capture, we are placing the marker on the external surface of the body, and that actually there is error in recording the actual movements of the joints, because we are unable to place the marker on the joints. There is difference of positioning the relationship between external body parameters, like, so this is needed to be established, that what's the exact relation between the external body parameters or external landmarks and internal skeleton, in order to remove or reduce the errors in joint location and consequent movement of the body joints. And if we can establish this relationship between these two, that is the external body parameters or external landmarks and internal skeleton landmark, then it will be easy to, it will be more the human, it will improve the realism of current digital human mannequins. This study also revealed that the gap between the relationship of external body geometry and internal skeleton is to be addressed in order to improve the realism of current digital mannequins skeletal model, specifically for a biomechanical analysis requiring information of joint load and muscle force estimation. Now, after discussing so many issues or so many future research direction by various researchers, now we are going to discuss another two reported literature information, where the researchers are actually giving future research scope of application of digital human modeling software. In many a times we find that application of digital human modeling software in a particular industry, that may be automobile industry or aerospace industry or agricultural sector, its application is limited. Sometimes, say for example, Sangjag et al. 2015, during the review on application of digital human model in aviation and aerospace industries, mentioned that presently applications are only limited or only confined to few aspects of aviation and aerospace industry. For example, many of the applications we can find in the area of cockpit design, passenger seat design, or accommodation in the spacecraft, maintenance application, but there are so many other aspects, so many other areas where this digital human modeling software can actually be used for evaluating those facilities. They proposed the use of digital human modeling software for the ergonomic evaluation of ground activities of aviation and aerospace industry, like security check, reception services afforded to passengers, including those of special needs, passenger baggage loading and unloading from aircrafts, and retrieved luggage delivery, and bulk cargo handling, ferrying of passengers from and through aircraft, and onboard passenger service, air traffic control, parking, and so many other areas. So Sanjay et al. In their paper, review paper, they tried to show that although application of digital human modeling in aviation and aerospace industry is going on for longer duration, or it started from long back, but again there are enough scope of application of this software or evaluating various other workstation or other facilities, because only people are concentrating in few areas of application, but there are so many other areas where this digital human software can be used effectively. Similarly, Patel et al. In 2000 in their review paper mentioned that digital human link softwares in agricultural sectors are mainly confined to design and development of agricultural tractor or vehicle, but there are so many other areas like design of hand tools, design of storage space, then tools and equipment design related to plantation, harvesting, post-harvesting storage, food processing. So in these areas there are still scope of use of digital human link software for achieving better man-machine fit or man-machine compatibility. Now after studying these earlier slides, now we can summarize that what are the areas where digital human link software can be used, or how we can improve digital human link software's capabilities to address various lacuna. So as it is observed that simultaneous analysis and activities of multiple mannequins are not possible in many of these software, so there is a need to address this issue so that simultaneously we can evaluate multiple mannequins activity. In an industrial workplace or where there is a assembly work where so many workers are working together, then simultaneously we need to evaluate their activities in terms of various ergonomic aspects like their posture evaluation, their muscle force, their comfort, discomfort. So all these aspects, there should be provision in the digital human link software so that we can measure all these aspects simultaneously for more number of multiple mannequins, not for a single mannequins, which is presently available. But we need to go for evaluation of all these aspects for multiple mannequins simultaneously. Next important aspect is multivariate statistical approach to generate boundary forms representing the target population. So for many of the software and also for many of the application, we find that researchers are using statistical model, a statistical mannequin of 50th or 95th percentile mannequin. While they are using those mannequin of percentile value, specific percentile starting from 5th to 95th, many a times it is not possible to accommodate the expected range of population. While they are using, researchers are using 5th percentile mannequin and 95th percentile mannequin, and they are expecting that 95% of the populations are included in their design, but actually it is not possible. There are many reasons. First, the body dimensions are not perfectly correlated with one another, and thus there will be different people may be outside this range from 5th percentile to 95th percentile, because one or more body dimension of a particular individual may be outside this 5th percentile to 90th percentile range, and for that reason they will be excluded. And if we check the how many percentage of the population or how much percentage of the population is excluded, then we will find that is a good amount. So for that purpose, not only this is the reason, another reason is in reality it is not possible to have one single individual whose all body dimension is of a particular percentile value. Uniformly large and uniformly small models do not necessarily describe the engineer's worst case scenario. For that, what happens? Combination of extremely large or extremely small values in the same subject may be critical for designing any facility. Next, model created from percentile segments are unrealistic in terms of size, in terms of shape. So for that purpose, researchers adopted a new technique, that is multivariate statistical approach. So with this approach, for this multivariate statistical analysis, we can go for principal component analysis. With the principal component analysis, what we can exactly do, from a large number of anthropometric variables or biomechanical variables, we can identify a small group of anthropometric or biomechanical variables which actually describe the larger portion of the overall variation created by a large set of anthropometric or biomechanical variables. So by this multivariate statistical analysis, like principal component analysis, we can actually identify a small group of variables which will represent the overall variation in the population, and through this multivariate statistical approach, creating boundary mannequins, we can accommodate a large portion of the population, and these boundary mannequins will actually represent the combination of smaller and larger body dimension. So from this small set of boundary mannequins, we will be able to represent various combination of larger and smaller body dimension. And while we are evaluating any product, facility or workstation with this type of group of mannequins which is actually representing the boundary forms, then we will be able to accommodate a wide range of population. So for this reason, although initially many of these digital human link software used percentile mannequin, but nowadays it is going to shifted towards boundary mannequins approach. And through this boundary mannequin approach, we can accommodate a large number of people for a particular product facility. Subjective evaluation for the product and workstation design. It is also important because right now all these evaluation are based on objective measurements by digital human link software. But what's the subject's opinion while he is working in a particular work environment? If the, say for example, we are going to evaluate a product, while we need to evaluate the form of the product or color or appearance or aesthetics, then those types of things right now we cannot evaluate with digital human link software. So for this purpose, subjective evaluation is required. So this is an area where digital human link software is further needed to be developed, so that various subjective issues can be addressed. So already in the earlier slides we have seen that many researchers have proposed that for this purpose we can use virtual reality, where real human can interact with the virtual environment and they can give their feedback while they are using the mock-up, and in this way we can reduce the cost of the actual prototype development. Moreover, for the subjective evaluation and for many other cognitive aspects, measure or determining the cognitive workload for a particular task, so these cognitive aspects are needed to be further researched for development of digital human link software. Then realistic human appearance and behavioral aspects are needed to be addressed. For many of the digital human link software, the human movements is robot-like or its appearance is also robot-like. So these human models are needed to be developed in such a way it looks like real human with real skin deformation, muscle structure, and its movements, its behavior should also mimic the real human behavior or real human motion. Impact of environmental factors of human performance and efficiency. So with most of the presently available digital human link software, the impact of environment on human performance and efficiency is not being assessed. So further research is required in this direction, so that in future we can use digital human link software for evaluation of environmental aspects like impact or effect of temperature, humidity or illumination on human performance and efficiency. Then comfort discomfort analysis, whatever is possible with the present digital imaging software, are mainly based on human body joint angles. So based on the human body joint angles, whether those various body joints are within the comfort range of motion or not, based on that we can evaluate the human comfort. But these are first thing, these are momentary observation. In that particular moment, how is the body joint angles, and based on that we are taking the decision about whether the human posture is within comfort zone or not. But while in a particular posture, although it is comfortable, but while individual is adopting that posture for longer duration, then how will be his feeling or her feeling, and how will be the effect of time on a constant posture. That type of evaluation is not possible with present digital imaging software. So in this direction, further research is required so that the comfort perception with longer time duration can also be assessed. Effect of age on mobility, field of view is needed to be explored. So for this purpose, database is needed to be developed based on joint mobility, field of view with the changes of age or advancement of age for human beings. Apart from this, there is also requirement for developing the vision analysis tool regarding the color vision for defined color spectrum, how much area people will be able to visualize. So those aspects are further needed to be developed. Integration of digital human models with immersive virtual reality system to enable real users to not only interact with the virtual environment but also with virtual human. So there is also requirement of integrating immersive virtual reality system with the digital human modeling system, so that the real user can interact not only with the virtual environment but also the virtual humans in those virtual environment. Then further research is also required in the direction of clothing and personal protective equipment. For proper clothing, we need to study the interaction of or interference of the clothing with the human body segment, clothing or interference between two parts of the clothing. Similarly, for proper fitting of the protective equipment with human body parts, those are also very important, and further research is still required in this direction for achieving optimal clothing design and personal protective equipment design. Then modeling of physiological aspects of digital human modeling is further needed to be developed. Many of these issues have already been addressed or are already being addressed in advanced digital modeling softwares like CentOS, and it was developed by it is being developed, still advanced development is going on under Virtual Soldier Research Program at University of Iowa. Other commercially available digital modeling softwares are lagging behind in this regard. So hence there is in near future more research is needed to address in all the above mentioned issues to make the digital human model as the representative of real human. So as in this section it is clearly mentioned that many of these aspects are being addressed by CentOS software developed by Iowa University. So for other softwares these are needed to be addressed. Only few of the commercially available softwares are addressing these issues, but for most of the digital human modeling software these issues are needed to be addressed. So these are the references. From these references various future research direction have been obtained. Now particularly I want to highlight the Virtual Soldier research and how they have developed digital human modeling software, that is the Santos. So for this purpose we will go to that site. So this is that web page of Virtual Soldier Research at University of Iowa. So you can see. So if you look at their web page, then you will understand what type of research is going on there. So they are developing musculoskeletal model, whole body vibration model. So 3D biomotion research lab, they are developing this whole body vibration model. Then various types of validation. They have already incorporated motion capture system so that they can directly incorporate real human motion data into digital human models. Then intuitive interface, then immersive virtual reality. They have already collaborated with another system of immersive virtual reality, and they have incorporated the their Santos digital human model in that immersive virtual reality environment. So as they have mentioned, the portal is a completely immersive virtual reality system. The portal can accommodate up to 5 people at a time, giving them the illusion of being immersed in the virtual world. Then there is physiological modeling, various physiological aspects are being modeled. They have already developed metabolic energy expenditure, calculation of metabolic energy expenditure during particular work, and based on that energy expenditure, they have converted that energy expenditure to the equivalent oxygen, that how much oxygen is being consumed to produce that much energy, and from that oxygen consumption they again calculated the heart rate, core body temperature, respiratory rate. So in this way, in the Santos digital human modeling software, we can also evaluate the energy expenditure, oxygen consumption, and based on that oxygen consumption, heart rate, core body temperature, rate of ventilation, etc. Similarly, various types of standard ergonomic assessments are possible there. Then zone differentiation, posture and motion prediction, they have already developed for predictive motion. They are using physics based forward dynamics. So they have already research is going on in that direction. So if you see here, the ability to predict posture and motion realistically is the crux and any comprehensive effort to model humans. So they have developed extensive capabilities in these areas using optimization. Then for they have also performing research in the field of spine modeling, then gait analysis, predictive dynamics. Predictive dynamics is a term coined to characterize the prediction of human motion in a physics based world. So they have developed this predictive dynamics to predict the human motion. Then again they have gone for modeling of clothing, realistic modeling, then human performance modeling, armor and soldier performance. So you can explore all this site for various advanced aspects of digital human modeling software, and in which direction present research is going on. So if we look at this advanced modeling of clothing, then you will find that presently they are doing research in the field of modeling of very flexible system clothing, then contact modeling between clothing and human, and self contact between portion of the same garment, then developing suitable constitutive, they are also developing suitable constitutive models that account for fibers comprising the fabric and their evolving woven or knitted structure in the garment. So in these various aspects, they are in this virtual soldier research for developing the Santos software for clothing modeling, these various aspects are being addressed. So they are, as it is mentioned, these 3 points: flexible system they are developing, then contact modeling, and also they are thinking about, or they are addressing the suitable constitutive models of fiber interaction for the clothing. So here you can see all these research areas. So for further exploration, you can click on all these menus, and you can get clear picture that presently in virtual soldier research, what type of research is going on for advancement of digital human modeling. Similarly, this I gave the example of CentOS software. Similarly, for other softwares also you can explore for Jack, SAMI, Ramsys. So you can explore individual softwares to understand what type of future research direction they have taken and they are proceeding. So that's all. Thank you.